Hello, everybody. Hope you're doing well, and welcome to another episode of Quack and Code. And today, I'm actually not the only mother docker which gonna be live. I'm gonna be joined by a colleague, and we're gonna talk actually specifically about MotherDuck today, but what it made so specific compared to DuckDB. We're gonna talk also about dual execution, how it works a bit behind the scene, what can you do when we work with the DuckDB client and MotherDuck. So we're gonna have a hands-on part. But so far, so good. And I want to welcome Stephanie on the live. Stephanie, how are you doing?
Hello. Hi, Mehdi. I'm doing well. Thank you. Thank you for inviting me to your Quack and Code live stream. I feel very honored to be here.
Nice. Where are you joining from, by the way?
I'm joining from the MotherDuck New York office. So, yeah, this is a small view of our little living room area, I guess. Yeah, right here.
Nice. I guess there are some ducks around.
Yeah, there are some ducks around for sure, and they're hard at work. Yep.
So can you tell us a bit? So you're a founding engineer. So you've been there since the beginning, basically, right?
Yeah,
And
right.
can you tell us a bit more about your background? Where were you working before, and how you came into MotherDuck as a founding engineer?
Absolutely. So I was at Google BigQuery before coming over to MotherDuck. I was primarily working on the BigQuery open source client libraries. So my primary focus was the Java client library for BigQuery, as well as the JDBC and ODBC connectors. And I was there for about 3 years. And then, so Tino and Jordan approached me about MotherDuck and wanted to see if I was interested in working on maybe like the client API services of MotherDuck and maybe the more ecosystem aspect of it. So I was very excited to work on something different. So I joined and started as a founding engineer. The
Nice.
interesting thing is, yeah, but actually, when I joined, DuckDB, as you know, already has an amazing coverage for their client API surfaces, right? So that they already have JDBC, ODBC, Python client, Java client, like all of these things. So there was not really a business need for us to change that. So then instead, I started working on the query execution part of things, and therefore the dual execution that you have mentioned,
Yeah.
because that is something that we wanted to kind of start to explore and build out. So actually, yeah, I've been working on the database team as a result for the last two something years. Yeah.
Yeah. And so can you tell us a bit like what the database team actually do? Because we have
Yeah,
DuckDB open source. So what's the main mission?
Yeah, for sure. So the database team is sort of like the middle part of the whole stack at the company. So essentially, we interface with the client API team on the surface area, and also the infrastructure team who build the foundation of MotherDuck, things like infrastructure, metadata management, and etc. And we're in the middle, and we work very closely with DuckDB to implement this query execution model that allows a query to be executed in MotherDuck, um, with the power of DuckDB, essentially. So we're kind of like in the middle over there.
Yeah, no, so that's great. So can you maybe we can dive a bit on uh, what is the main feature difference basically a DuckDB um, embedded standalone and MotherDuck itself, because that
Absolutely.
MotherDuck is running DuckDB behind it, right? But there is this
Absolutely.
this layer basically um, that you mentioned, and maybe actually we can take. I don't know what you think. I have the C cider paper schema, so
Yep.
maybe we could take that one to kind of illustrate. What do you think?
Yeah. Yeah, for sure. Absolutely.
All right, wait. Let me here. So um, so basically we have DuckDB here on the back end of MotherDuck. And maybe I can give a quick context for the audience. So this is actually the CIDR paper. Can you talk a bit, explain to us maybe the conference and on which context this paper was written?
Yeah, absolutely. So I would say there are probably three most prominent database conferences out there globally. One is SIGMOLD, which just happened 2 weeks ago, and that is a very large conference. I was there actually about 2 weeks ago, and there were about 800 researchers, database researchers, and database slash AI researchers at the conference. And then another one is VLDB, which is also quite large and very established. And CIDR is the third well-known, well-recognized conference within database community, but it's much smaller. So has less than 100 people each time, and everyone kind of participates in all of the tracks. And so this paper was presented at the CIDR conference, I think last year.
Yeah. Okay. And so this basically means that so that was a paper that gave information about MotherDuck architecture, talked a bit what we're going to talk to today. And it was from January. It feels like a decade,
Yeah.
right? I guess for you also.
Yeah, yeah, for
Yep.
sure.
Things are moving
Yeah.
moving fast. But yeah, coming back to the main component that basically had MotherDuck as a layer on top of DuckDB, can you walk us through that?
Yeah, absolutely. So MotherDuck is a pretty complicated system at this point. However, it can be mostly summarized as three key components. So the first component is the client layer on the left-hand side over here in the diagram you can see.
Mm-hmm.
So this client layer can be any type of client APIs. So here's an example of Python, but we also have lots of other people connecting to MotherDuck through Java. For example, the JDBC connector is a popular one. And another popular client is the web browser. So the browser actually is really cool because we essentially run DuckDB in the WASM build.
Yeah.
So it essentially leverages the memory in your browser, and that's really amazing.
Yeah.
So that is,
Yeah,
mhm.
it's just to give a pause for people. So if you go to MotherDuck UI and if you run a couple of queries, you're going to fetch some data from the cloud. And then if you do some pivot or other operations, that would use your DuckDB, which is in the browser, right? So in WASM, to avoid any network traffic. So this is pretty new because then it's, as you said, it's leverage your browser memory, but it also avoids extra compute cost on the cloud, right?
Yep, exactly.
Yeah. So so MotherDuck web browser and the client, and also another call out is that if you go on our documentation, you can see actually documentation for the different driver that we have that we support.
Yep, exactly. So essentially, this client layer is also, so this is where MotherDuck kind of plugs in, right? So this is also the part where we call it a client extension for MotherDuck. We very strongly depend on DuckDB's extensibility. So if you have some familiarity with DuckDB, I'm sure you've heard about DuckDB extensions. So it's quite similar to Postgres, actually, where they have extensions and you can use DuckDB as a library, essentially. So MotherDuck, we do not fork the open source DuckDB, and instead we leverage this extension ecosystem. So we have one kind of extension running on the client side. That's our client MotherDuck extension. And then we have a server side extension, which runs on the compute layer, this middle part of this diagram, essentially.
Yeah.
So,
and I just like to call out because I wanted to talk about this, and I think it's nice that you bring it up. You mentioned that we do not fork DuckDB, right? We rely
Right.
on the
Yeah.
same thing, and I think that's a big difference from traditional managed database that we know, like Postgres, MySQL, Elasticsearch, are available in different cloud provider, right?
Yep.
But they often, rely on a fork, and which means that when there is an upgrade on the open source project, it usually take weeks, months, or sometimes year. I know, for example, for Apache Spark, for example, for AWS, to follow up, with the different version, it takes some time, quite some time because there is tight integration done given a specific cloud provider. But here, the power of not forking make us basically able to upgrade much more quickly. Is that correct?
Yeah, absolutely. I would say so.
Yeah.
Yeah.
So that means that actually for GA we went GA, the second day after that DuckDB was released their 1.0.
Yep.
So yeah, that's a pretty nice and differentiator. So yeah,
Mm-hmm.
you talked about the plugin, the extension, how we basically connect to MotherDuck.
Yep.
We'll see after. Actually, we can do a quick hands-on maybe just to explain so that people picture that rather than just at the end.
Yeah.
Um,
Yeah.
so just the connection. Um, so if I'm running a DuckDB CLI, you can install it if you're on macOS to brew install DuckDB. But basically, you have a table which is extension. So this one,
Mm-hmm.
which are you using sometimes this table extension?
Yes, I do actually, because it kind of gives me a good idea of what are the extensions that I have loaded
Yeah,
on my system at my disposal. So if an extension is installed and loaded, that means I can exercise the functionalities in that extension.
yeah,
And I can also check some other, parameters on the extension, versions and things like that. So it's
yeah.
helpful to inspect it.
Yeah, so that's basically exactly that. So you can see all the extension, and a lot of them get installed automatically based on certain function and certain hook. So DuckDB has but certain hook that if you query, for example, an S3 file, so you do from S3 to point, and then your file, for example, like this. What's gonna happen is basically it's gonna load the HTTPS function to create to download read remote file, and it's gonna also load the Parquet, and you don't have um, to do anything.
Hmm.
But otherwise there is a mechanism, right, to install and load an extension,
Yeah.
right?
Yes, absolutely. You
Which
could
is
also,
yeah,
yeah, you could also explicitly say install extension name and then load extension name.
yeah,
That will bring in whatever extension that you're interested in bringing into your picture.
yeah,
DuckDB is very smart about this because this allows them to keep their core binary very small,
yeah,
because not everyone, for example, is going to analyze geospatial data, for example.
yeah,
So, and spatial extension that DuckDB offers is actually quite a large one. It has quite a few dependencies, for example. So, to reduce the build time of their core project, they have, basically put all of these other functionalities sort of in these extension out of tree extension repositories, so your core functionalities are unimpacted and very small, very nimble and easy to build, portable and easy to use.
yeah. And also a call out, DuckDB is working on community extension to be installed directly. So they're going to be a framework where, because this is our officially supported extension by DuckDB Labs, and if
Hmm.
you want to create your own and install your own, usually you need to add an URL or to be able to download that extension locally. But it's going to be much more easier in the future. It's actually already there, but not advertised it yet.
Yeah.
But anyway, coming back to MotherDuck, uh, MotherDuck is an extension, right? So
Right.
um,
Exactly.
So we have actually here, right?
Yeah, we are listed. Yeah.
So yeah, so we are listed as an official supported extension, which means that also you don't need to install or anything to log into MotherDuck. You can do an attach command like this, and attach command is used to attach a database DuckDB file, for example. But here, basically, if I do this, I'm going to attach and connect to MotherDuck. And because I have my environment variable store as the MotherDuck token, which is the only requirement to connect, I can now show the database, which are those one are the cloud database that I just showed earlier in the UI.
Yep.
And that's pretty much it to connect to the cloud. So that's pretty great.
Yeah.
Yeah.
And this is also why we didn't have a need to work on top of like the DuckDB client APIs, because it's so easy for MotherDuck to come into the picture. So no matter where you are using DuckDB, you can easily connect
Yeah.
to MotherDuck just by using this command you've shown.
Yeah.
And in other cases, maybe modifying a connection string to prepend MD colon. So super easy.
Yeah. Yeah. So yeah, as you mentioned, would it be Python, Golang, or whatever? It's always the same process. You attach MD with the MotherDuck token, and you're connected
Yep.
to the cloud.
Precisely.
So coming back to this one, no, not this one, this one.
Yeah, exactly. Yeah, so coming back to the diagram here, so just want to again summarize here that our client extension in MotherDuck, it modifies DuckDB in many different layers. So the lifecycle of a query starts with parsing of the SQL, and then it moves on to binding, which does catalog lookup to figure out how to construct a logical plan from the SQL string. And then optimization comes in, and then eventually we produce a physical plan with different operators so we can execute this query in MotherDuck. So MotherDuck extends the parser, it extends the binding, it extends the catalog lookup, it even extends the optimizer and the storage. So we really, really leverage the DuckDB extension system here.
Okay.
Yeah.
So yeah, so so there is a lot extended, and then maybe so you have. Can you talk maybe on the main components that there is here?
Yeah, absolutely. So basically, if we focus on the middle component over here, obviously, before coming to MotherDuck, we have all of this, observability, monitoring, authentication, load balancing, users and secret, all of these things. So this is also, to show why it is difficult to just run DuckDB in the cloud on an EC2 instance, right? I mean, sure, it is doable, but to do that properly, to do that with reliability, with security, with access control, with proper monitoring, like all of these things with observability, it requires quite some work, and that's where MotherDuck sort of comes in.
Yeah.
So essentially, on the server side, in this box on more like the right hand side over here, we basically have these containers that kind of just run DuckDB on the server side. So basically, these containers are of different sizes depending on the user's use cases. So they vary in terms of number of CPUs and also amount of memory. And of course, we fondly call these containers ducklings. So we we have these ducklings running on the back end for you that like sort of process your queries essentially.
Yeah.
Yeah. And also so because we have also separation and decoupling of compute and storage, which is obviously typical for cloud systems nowadays, right? So data is eventually managed in cloud storage using differential storage. So that is how we manage our storage, and that allows in place updates which is very powerful and allows us to do time traveling and database sharing and snapshotting very easily. So that's another part of why running DuckDB in the cloud can be challenging, is that you can do it, but to do it efficiently and cost effectively, you need to potentially introduce your own file system to manage your storage layer essentially.
Yeah, yeah. So that's already a lot, and I think one point is that we often see is that if you're using DuckDB as a standalone person, but then as soon as you need to share the data or work together, right?
Yeah.
You're gonna hit some limits. What are the main limits? Are you thinking of, like, going from single player mode of DuckDB to multiplayer mode?
Absolutely. So, for example, if I am working on, some analysis in my database, and maybe I've, produced something that I think is worth sharing with my colleague. So if you only have your DuckDB on your local computer, you most likely will have to share the SQL, to regenerate the state that you are currently in. And you also have to share the database file in some way or some query to generate that database file, and so that your coworker, who is somewhere else, can then be in the same state as you are. However, with MotherDuck, database sharing is one of the key features that we offer. So people who are part of the same organization can share their databases very easily. So instead of having to write all these SQLs multiple times and figure out how I share my database files and raw, database files, I can just create a database share, from my database, and then my colleague can then go ahead and just, um, query on top of that database share, and that just makes collaboration a lot more, natural and a lot more easily.
Yeah.
So that's one thing that we really would love to like highlight, at MotherDuck.
Yeah, so the database share, for example, if you log in today as to MotherDuck, you're gonna have a share actually already attached by default for any of the user, which is a sample database. And so in this sample database, you have a couple of examples data set from Hacker News, Kaggle movies, taxi New York City data. And so you can query those, you can create a new database easily and then share it with others. And I think what's important to mention is that behind the scene is we are leveraging the DuckDB file format, right?
Yes, yes, absolutely. So we are storing our data also just in the native DuckDB file format. But I do want to mention that DuckDB storage is designed for local storage. So a single database file means that dropping a table will leave a hole in the middle of your database file. And this file will then be reused and updated later. So even appending a new table, using columnar storage could generate IO that leaves gaps basically, and write at multiple places in your database files at the same time. So this type of implementation that is fine for local use cases is not actually very cloud friendly. So therefore, MotherDuck has implemented a user file system called Fuse. So that appears to be a random writable file system, and it can be mapped to S3.
Yeah.
So essentially, we store a logical database file in multiple snapshot layers. And we have a blog post, by the way, on how differential storage is implemented and envisioned, essentially. And so every single write that happens in the database will go to the active layer
Yeah.
and is append only. And it keeps on mapping mapping this which position in the layer correspond to which logical position it is in your database file.
Yeah.
So,
So
so yeah,
so that's important to mention that, like, if you have multiple user, writing, reading, or doing the operation to the um, same database file, you can enter to some limits with the native one, and that's where when you move to the cloud and you need collaboration and multiple people working on the
yep,
same data set. Uh,
exactly.
you
Yeah.
you feel some limit. And so this is the blog, by the way. I'm gonna quickly share it in the
Yep.
in the chat.
Yeah.
But yeah, so that's already a lot of points. So coming, I'm not sure if we have cover the storage services, um,
Mhm.
and the Decklink container. Maybe you can talk a bit about the user secrets
Yeah, absolutely.
because you
So
worked on that, right?
yeah, I did work on that. It is my baby. I'm very happy about how the secret manager is now. So we co-designed and collaborated with DuckDB on the DuckDB and MotherDuck secret manager. So essentially, this secret manager is supports a pluggable secret storage. So DuckDB has the secret manager implementation where it can oversee all of the secrets that you have plugged into DuckDB. So MotherDuck, for example, is one of the designated secret storages. So essentially, whatever DuckDB supports on the client side in terms of secret types and parameters that you can store for a given secret, all of any of that stuff, MotherDuck supports the same. And if you want to store a secret in the cloud as opposed to only locally in memory or in maybe in your local file in an unencrypted format, you can simply just say create secret in MotherDuck or simply say create persistent
Yeah.
secret when you are already connected with MotherDuck. And then that will create you a cloud persistent encrypted secret in MotherDuck cloud storage.
Yeah.
And the benefit of doing that is then you can easily reuse that secret and you can query whatever bucket you have in various cloud storages we support through DuckDB, S3 of course, GCP, Azure, ABFSS as well, Hugging Face now for those people who are running ML workloads, and many more. Even Unity Catalog is another new type of secret that DuckDB introduced with the support of Data Lake table format, which, by the way, we now support as well.
I was
Um,
waiting for you to put that plug, right? Because
I
Stephanie
hope.
also Stephanie also put a lot of effort on making the Delta Lake. Can you walk us about a bit the challenge, like of make it work an extension like
Absolutely.
that in MotherDuck?
Yeah, absolutely. So DuckDB supported Delta Lake as a table format, I think maybe about 3 weeks ago or so. So we wanted to also support that in MotherDuck. So, straightforwardly, people would think, okay, wouldn't that just work? Since it works in DuckDB, why
Yeah,
wouldn't it work in MotherDuck? So I think part of it is also because we are doing the dual execution. So that complicates things in some extent.
yeah,
So essentially, we have this kind of bespoke mechanism where we have an optimizer extension that plugs into DuckDB optimization logic where we do our own optimization. And our dual execution essentially identifies when is a good time to execute something remotely in the cloud versus locally on your machine. So Delta Lake, for example, when you're scanning over S3 files, that would be a remote operation. But if you scan over a local file, that would be a local operation. So
yeah.
we need to integrate this into our system in such a way that it would work naturally with our existing dual execution framework. And it needs to also work in WASM, which is always a special snowflake, obviously. Um, not to mention, and this ties back to the earlier point I've made about why it is difficult to deploy DuckDB by yourself, because we also build extensions in many various architectures,
Yeah.
right? So we build our extension in Linux, ARM, Linux x86, in Windows, in OS X, of course. So we have a handful of architectures we have to build for to make things easier. And Delta Lake in this case actually uses the Delta kernel library written in Rust
Yeah.
that's offered by Databricks.
Which is
So
new, by the way, right?
it is in experimental stage right
Yeah.
now and gaining adoption as far as I saw when I worked on this. So that means bringing in Rust as a new dependency into MotherDuck's code base as well. So of course you'll run into various problems as you link this library in various architectures on our end. So DuckDB only builds Delta Lake extension for I think 4 architectures so far. I believe Linux. x86 OS X is there as well. I think Linux ARM maybe not yet released, but we actually build Delta Lake for all of the architecture supported by DuckDB.
Okay.
So you can do a simple from Delta scan, and then you pass in your Delta Lake path. It could be a local path or it could be a remote path in S3, for example. And then you can interact. You can create a view on top of that, create a table on top of that, or directly, interact with it. And before doing that, you just have to create a S3 secret. So that is the
Yeah.
requirement for Delta Lake, and then you can work with it in a super like easy, intuitive way. Yeah.
We'll go to an example of creating secret and comparing local client without MotherDuck querying S3, and then with MotherDuck right after. Um, so if I look at I lost actually the Cider page.
Mm-hmm.
Let me go back to uh, here. Yeah, so I think we cover most of the different things
Mm-hmm.
that you mentioned regarding secrets. It's true that if you run on your own DuckDB on a Kubernetes cluster, whatever, you need to manage how you're gonna pass those secrets, and
Mm-hmm.
there we can store it in MotherDuck, and just that would work out of the box.
Yeah.
And yeah, I think we cover most of the thing. Can you talk a bit like what you contribute so far in DuckDB open source, because like that's um, a good point to mention, like what kind of contribution MotherDuck has been doing so far for the DuckDB open source project,
Yeah, for sure.
and a bit yeah, and maybe based on your experience, like what's the easy way to start contributing to DuckDB open source?
Absolutely. So I started working with DuckDB about 2 years ago as well. Once I started at MotherDuck, I think the very first set of contributions I've made was around serialization, because the way we've opted for dual query execution, where we are breaking the logical query plan down into different parts. So that requires all the logical operators and table functions to be serializable for MotherDuck,
Yeah.
because we have to make gRPC calls and we need things to go over the wire. So this is not something that DuckDB really needs. DuckDB is again local and everything is in memory. But because of MotherDuck, they uh, very very happily agreed to implement the serialization logic in DuckDB. So I was the person who went and added serialization code for all of many of these logical operators, at least for all the select ones. And then later on, I think Mark at DuckDB refactor some of these things. So nowadays the serialization code looks quite different, and they use a different code generation mechanism. But at the beginning days, it was quite manual, and so I worked on that. And then later on, I worked on many different things. One of the things was, of course, with Sam on the secret manager. So we designed it together, and Sam, of course, did a lot of the hard work of putting in the basic infrastructure, and a lot of the functionalities was written by Sam. But since we're the number one adopter of the secret manager, the very first integrator of the secret manager, so I also discovered some of the missing spots, I would say, and some of the nicer to have features. So I contributed to that as well. And then many other things depending on what we find in MotherDuck, because MotherDuck sort of puts DuckDB in a production setting,
Yeah.
and we're testing and using DuckDB in the kind of scale and pace that DuckDB was not tested
Yeah.
for in the past. So
Yeah,
It is
that's a really good point. It's like, I mean, aside from the contribution you mentioned, is that we are also kind of like the beta tester at scale because,
yeah,
I mean, it's not necessarily us directly. We do have, load balancing tests
of
and so
course.
on. But our users, suspectively, would grow. So the more user base we're gonna have in the usage, then basically that's gonna push, I think, also DuckDB to its limits, right? Or
Absolutely.
further push. Yeah.
Absolutely. So we're kind of the beta testers in many, many fronts. So one recent issues, for example, that we discovered and we communicate with DuckDB was, okay, we see a connection error once you've had 1,000 connections open while reading Parquet file, right? So that happened to us. User was using MotherDuck in such a way where it's concurrently in parallel opening up 1,000 connections to read Parquet files. But in DuckDB, perhaps the data science users or data engineer users didn't commonly have that kind of
Yeah.
workload, so they didn't detect this issue. And we're also I would say the very first people exercising the data lake related features such as iceberg scan and
Yeah.
delta scan, right? So they're very new, they're in place, and I think being able to support data lake use cases for users at MotherDuck is super important. I think data lake will be first class citizen at MotherDuck in no time. We really, really want to get this right, and in order to get that right, we need to do that in collaboration with DuckDB. So with DuckDB, we want to have good performance on, of course, S3 Parquet reads. We want to have good performance and good feature coverage for Iceberg reads and also Iceberg writes, hopefully soon, and also delta, not just the basic scan of the entire table. We
Yeah.
want also filter pushdowns. We want projection pushdowns, different things, right? Optimization on top. So I think that's going to be critical for MotherDuck's success, and also I think it will help DuckDB's adoption if they improved on these fronts as well. So it's really, I would say, a win-win situation, for both MotherDuck and DuckDB, that we are kind of the first beta testers here.
Yeah, no, that's great. That's great to mention. And regarding Delta Lake, I mean, we've talked already enough because we're gonna have a dedicated session with that with someone from Databricks, actually,
Mhm.
where we're gonna dive in the end zone. So we have 20 minutes left. So I suggest we start a bit more to play with the CLI.
Yes.
And so what do you would
Sorry.
like to? Yeah.
Sorry, I forgot to answer your question earlier about contributing to DuckDB.
Yeah, that's
I
true. Sorry, I completely missed that.
sorry.
Yeah.
I
So,
forgot that I want to encourage the viewers and listeners
yeah,
to consider this seriously. Is that I think it's super easy to contribute to DuckDB. You don't have to be working at MotherDuck or any associated big company or small company in order to contribute to DuckDB. The reason why is they are an open source project, and all of their issues, a lot of their issues are just out there on the open source repo. So if you go to github.com/duckdb, you will find the issues tab, and they literally have like hundreds of issues open, and they're very good at labeling their issues. So if it's something that they've already kind of looked at, they will label it. Okay, this is reproduced, and this needs triage, and this is something that's under review, and things like that. So as a new contributor, you could find something that is not too big, that that's already something that's being reproduced, and then you can start with cloning the project, and just building the project, and then maybe running through the unit tests, and then you can write a test that would fail initially, and then you would debug the code with your debugger setup, and then you will just make a PR against a repo, and they're really, really good at code reviews. So you will get your code reviewed very quickly, like within the day or two, essentially.
yeah,
And this is not just their main repo. Like I mentioned earlier, they have a very extensive extension ecosystem as well, right? So that means they have DuckDB underscore iceberg, DuckDB underscore AWS, DuckDB underscore Azure, and DuckDB underscore iceberg. All of these repos are open source, and all of them have a issues page, right? So if you go to any of those extension repos, you go to their issues pages, then you will also see outstanding issues that are particularly related to the extension itself, right? So then if it's something that you're interested in fixing or improving, I hear lots of words about people wanting to improve iceberg functionalities, for example. Feel free to do that, right? Feel free to go take a look at what are the existing issues. If there's something that you feel like is immediately actionable, then pick it up. Or if you feel like you want to propose something, you want to discuss something, then create a discussion topic. And they're very, very open-minded and willing to discuss at all times. So
Yeah.
yeah, that's
No,
on that.
that's a good call out. And what I would add is that DuckDB is built in C++, and that's blocked a lot of people. But you actually don't need to even know how to code C++, or even barely to code. Actually, if you only knew SQL, if you are a DuckDB user, you face an issue, you can reproduce that issue. That's what love people is to be able to reproduce. So having the SQL query, having the data set to reproduce your issue. And if you create a GitHub issue regarding this that you can reproduce, that is really valuable. That is not coding at all, right? It's like you identify a problem that is can be reproduced. And aside from that, there is also just the documentation. Documentation is also, a team effort, and sometimes things are missing or not correct or could be added. If something is not clear for you in the documentation, it might probably be not clear for someone else. So it's worth to just open a discussion, right? There is also GitHub discussion. You can just open a discussion if you're not
Yep.
sure to create an issue.
Yeah.
Yeah.
100%.
So that's the two thing I wanted to call out. All right, let's go back to the terminal. And what I would suggest, what do you want to start? You suggest me before starting a couple of things, right?
Yeah.
Um,
Did you want to show maybe creating a secret
yeah,
in MotherDuck, and then maybe we can run through scanning of Parquet, and I also just want to show the MD run
yeah.
parameter that I think most people actually are not familiar with,
I'm
but it's
not yet.
actually
I'm not
yeah,
even like using it. I think I used it once, like a couple of months ago. But
yeah,
um,
yeah. Nice.
so yeah, we can start with that. So you had the example of using the TPC Edge extension, right? Is that correct?
Yep, yep, we can do that. But yeah, we could generate. Did you want to show like the query plan with that?
Yeah, we can do. Maybe we can start with the query plan.
Mm-hmm.
I'll generate locally.
Yeah, sure. Sounds good.
Um, what kind of factory do you suggest there?
Oh, we can do 0.01, or actually, do you want to generate in a MotherDuck database? So what happens is if we create a database, if we say create database, maybe like CloudDB, and then
Yeah,
we say use CloudDB, that automatically drops you into a remote MotherDuck DB. So
yeah,
super easy like that. And then once you've said use CloudDB, then that will generate this TPCH
yeah, yeah,
dataset
yeah, yeah.
in the cloud DB. Yeah.
Yeah, so we can definitely do that. So I'm gonna connect to MotherDuck again to an attach. So
Mm-hmm.
now I'm there. I'm just gonna zoom out a bit for the people, for the audience. And let's create a database.
Mm-hmm.
You know,
TPCH, may just TPCH, make it
yeah. I'm just
clear.
thinking if I didn't have any already this one.
Okay,
Um,
perfect.
Yet. So I'm basically there, and so now what I can call is db.
You can say call dbgen, and then we can do like a 0.01.
So what it does is actually calling the extension, right,
Right,
to uh,
exactly.
for TPCH, right, data
Yes,
set. So
exactly.
DuckDB has a building extension for TPCH, which is um, a set of open data set for comparing database benchmarks. So
Mm-hmm.
it's really easy to just generate fake data that you want to try and test. So that's what we're gonna do. And
Yep.
so now it's done. And if I do show table, this is the table that has been created, right?
Yep. Sounds good. Yeah. And now we can do a simple join and aggregation query to show how many customers there are in a given nation.
Yeah. So I think you give me this query before.
Yep.
Uh,
Yep.
so let's run this one. So that's a count per country. Can
Yep. Perfect.
Yeah,
So here, as you can see, the query is referring to the customer table and the nation table, and these are in your remote database that's in
yeah.
MotherDuck. So this query is being executed remotely. And how do we know that? If we simply prepend explain in front of this query, we can see the query plan that was used to run this query.
All right. So yeah, can you talk to us a bit about I just run and explain. So what is happening here?
Yeah, so the explain plan will give you the physical plan that is used to determine exactly how this query is going to be executed. So before the physical planning stage, we had the logical planning stage and there was the optimization stage. So during that optimization stage and planning stage, the logical planning stage, we determined, okay, so this is a remote table that you're querying here. So we're going to go ahead and execute this query remotely. So therefore, the physical plan being generated here reflects that decision that, okay, we're going to go ahead and execute this remotely. And when you execute this remotely, so on the logical side, we insert a bridge operator that we call to kind of facilitate this uploading and downloading of data. So in your physical plan, you can see that all of your scans, all of these operations were done, the projection, the
Yeah.
hash join, and the sequential scan, all of these are remote. So
Yeah.
they're
So that's
no
the R here, right? Yeah.
right, exactly.
And
So
this
the
is
little
local.
correct. However, that is local because essentially that is where this query is going to download this data, from remote to local, using this bridge, and the bridge ID is one.
Yeah.
So that's how you can see that this is a remote query, but eventually you have to have your data back on the client where you are seeing this on
Yeah.
your
Here.
terminal right here, right? So that's where your local comes in.
Yeah. All right.
Yeah. But however, we can also show how to run this query kind of, in a dual mode. So if we copy the table to a local file, so if you run the maybe copy customer to customer parquet, then that will like copy this data to your local
Yeah.
essentially.
So let's say yeah, customer.parquet.
Yep, that sounds good.
So
Right.
now I have, let me actually open, I'm not sure if I was in my home directory, but yeah, here it is. So I have the customer parquet here, which is a really small data set that's been copied from the cloud to locally,
Right.
right?
Right,
Okay.
exactly. Yeah, so if we modify our original query to say instead of selecting from the remote table, but instead we select from customer.parquet, so that's going to actually select from your local customer.parquet file.
Yeah. So here, basically.
Yep, you can switch that to customer.parquet.
So yeah, that's okay. So there is a lot of things that are happening here, right? Because like first
Yeah.
of the thing, I mean, we talked before that, but here also in terms of extension, we didn't have to specify, the file format extension or whatsoever. I just specify the extension of the file, and it knows that you need to write it as a Parquet file, right?
Mm-hmm.
And here, and so this is downloading remote from the cloud to local, right?
Right,
And
exactly.
and here we are joining a Parquet file with a local Parquet file with a
Right.
remote table.
Nation table. Yeah.
That's correct?
Yeah, exactly. Yeah.
Okay.
And again, we can see this with and explain
Yeah.
clause again, like
All
all
right.
of this thing that we have said. Yeah. So now you can see this is a much more interesting query
Mm-hmm.
plan. Unlike before, everything was remote, and now you have remote sequential scan, and then you have a batch download sync that's remote, and every single sync is matched with a source on the other side. That's going to be either local or remote. So you always have a sync and a source pair essentially,
Yeah.
and this, and then yes, and then if we go up, you will see eventually, we're doing these logical projections, all of these things happening on your local file locally, essentially. So
Yeah.
that's what happening with your customer dot parquet stuff. And then, finally, you're downloading your data back to your client. So that's going to be a local operation as well. So this is how, this query was executed in a
Yeah.
dual mode as opposed to fully remote. And why that is the case is because one of your tables is actually local, and there's no reason to have to migrate that data. And instead, we just computed leveraging your local compute right on your computer. So you have this plan as a result.
Yeah. No, so that makes a lot of sense. And basically we are leveraging the local DuckDB client here to do part of the compute,
Of the
right?
operation.
Yeah.
Exactly. And it may not be super obvious here because customer.parquet is a relatively small file. But if you have a much larger file, this will be probably more obvious that this is going to be a lot faster.
Yeah.
And this is especially prominent when you're rendering something in the browser, especially if you're trying to have some sort of graphic. You are trying to drag a bar, for example, and you want to see the graph respond to the position of your bar immediately without any sort of latency. So that makes local first execution in this case very, very appealing. But again, it's not always local first. In MotherDuck, it is a dual situation here. It really depends on how big your table is, how large your data is, and where you're executing from. That then we determine, optimistically, like kind of how to optimize your plan in such a way where it will execute in the most efficient way.
Yeah.
Now, with that said, there are certain customers or people, users, who want to just dictate, I want to run this thing locally only, or I want to run this thing remotely only. Um, I have seen both cases. So, of course, someone who want to just run something locally, they want to do that perhaps because maybe they don't want to share their credential with MotherDuck, right? So they want to just execute something locally with their local in-memory credential, so they don't persist this in the cloud. Or perhaps, if it's R2, which is, kind of edge, storage, you may want to run your query locally, but really on edge. So that's closer to, where the data is stored. So there's a reason why people may want to have that capability. And
Mm-hmm.
that's the reason why we have introduced the MD run parameter. That can be used for all of these DuckDB scans. So Parquet scan, CSV scan, Delta scan, Iceberg scan, all of them. You can declaratively just say, read Parquet, and then you pass the path of the Parquet, and then you can just say MD run equals local. So then that will be executed locally. But if you say MD run equals remote, then that will be executed remotely. So you can determine that for yourself as well.
Yeah. So here, of course, if my file is local, it will perform locally. I cannot force to a read, but basically the syntax will look like.
Yeah.
The,
So we have
actually, you have to
we need to
specify.
say
Yeah.
Parquet, yeah, because we need to pass this parameter in.
Yeah. So you have an extra parameter, and so it's
Yeah,
going to be
precisely.
Mar Parquet, and then
And
MD
then MD
run,
run, yeah,
and then
equals. You have to
local or
parentheses.
remote. Yeah.
Yes, you have to use parentheses there. One pair of quotes, just
Yeah.
one single quotes that says, let's say local. Yeah, even though naturally this would have been run as a remote query in MotherDuck because we see that you're trying to scan a remote file. So one thing to note over here is if you're trying to run a S3 file completely locally, this will involve a downloading of the data, right?
Yeah.
Like in the backend, like the DuckDB HTTPFS file system, when they execute this, they're going to download it. So it is important to check the permission on your bucket as well, because if there's permission, forbidding the operation of downloading or something like that, you might run into some type of permission error. But if the permission front checks out, then this will just like
Yeah.
run, without any issue. And
Yeah, maybe we can try to do this because we are closing to the end already. But we can. I have an example actually where we could do a specific query on a relatively large S3 file, one without using MotherDuck and one with. What do you think?
Yep,
So,
sounds good.
so I'm gonna load my AWS credential. So the right side is connected. It's just DuckDB connected to S3, and I'm gonna do a live side where I'm connected to MotherDuck. And so to create a secret, this is the only thing I need, right, to specify.
Correct. Yes, exactly. So you can also, for people who are used to doing AWS SSO login, prior to running this query, if you just simply do AWS SSO login, this is going to be creating the secret using whatever login credential you've had with that. So it's super straightforward. You do not need to type in all of your credential information here.
Yeah.
You can just specify credential chain.
Yeah, that's a good point that I did do an SSO logging before. And I did also added already this, so I don't need to do it. And I'll maybe just show quickly in the UI. You can see actually that actually I have the UI right there. So that if I go to secrets, I have this secret which is already created and stored, right?
And another thing to mention is a lot of people, because they're part of a larger organization, when they do AWS SSO login, it may be a temporary credential that expires in, say, 8 to 12 hours.
Yeah.
So I think one thing that DuckDB is looking to work on is token refresh, so that we will have some sort of client-side mechanism to know when a credential has expired or something like that. But for now, if you have temporary credential and that might have expired, so then you will just do a create or replace secret, and then you do the same credential chain command. So that will then pull in your newest credential.
Yeah. Okay. So yeah, that's a good point to mention. And so I have a data set which is this one, which is a pretty long actually query, and it's actually PyPI data. The data set is roughly 2 gigabytes, right? And I'm doing basically aggregation, so it's representing each row is a download in PyPI, so on DuckDB project. And so this is using basically MotherDuck. Maybe we can do, let me do a timer. Always forgot. So what I did is just timing to see who's going to be fastest. So let me, so this sounds good, I think. I have an explain in front, which is not what I want. All right. So I'm gonna run this query. It's gonna take some time, and here I'm gonna basically run the same query, and hopefully. And so this is not using MotherDuck. This is just using DuckDB and S3. And so here we see that we have, 25 seconds. But here what's going to happen is that it needs to download the data, right?
Exactly.
And
Yeah.
so the larger your data set is, which is here, it's still relatively okay. It's less like I filter out, so it's less than 1 GB this data of 4K. But you can see that the more you need, the more data you're gonna need to have on remote, the more you're gonna need to download, and so that's a lot of traffic I/O. So that's what we explained earlier, right?
Yeah, exactly. Um, yeah, exactly. So that's a great example, by the way, Mehdi.
Yeah. So yeah, so that's about it. I don't know about the timing. I think it was a bit longer here. I do have a good internet connection here,
Mhm.
so that's
Great.
actually that might be suspicious. But again, so you can compare yourself if you I forget to put the timer on, but if you put the timer on
Yeah.
and you run this, you're gonna see the difference between MotherDuck cloud using S3 and local S3.
And your where is this bucket located, Mehdi?
US East one.
Okay, that makes a lot of sense also, since you are streaming from Europe, and MotherDuck happens to also be in US East One. Hooray!
Yeah, exactly, exactly.
Yes.
All right, let me just uh, uh, wrapping up things. So yeah, thank you, Steph. I think it was great. We learned a couple of things on the different components of what makes MotherDuck special. We had a hands-on part showing the explain with the local remote, how you can actually force also some execution to do locally and remote, and we saw the performance difference, and actually have the results here. It's not even a big data set, and again, let me share again here. So you see we have 36 seconds, and here 25 when using MotherDuck. But
Yeah.
you can do your own test based on your use case. You can also join local data, so that's what we did in a remote table.
Yeah.
So that was pretty fun.
Yeah.
Yeah, anything you would like to add?
Yeah, I think I was super happy to be here, and that was super fun, Maddie, and it was really cool to see your demos and all the hands-on exercise. So I just hope that the viewers now have a better understanding of how dual execution at MotherDuck works, and the real challenges of deploying DuckDB in the cloud, and how to do that properly, in the sense that we want to do it securely, reliably, and cost effectively, and also accessibly. There are just so many things involved with getting this product to work easily for people. It's not just about getting it to work, but
Yeah.
we really want to make it work well for our users. And so a lot of challenges come from making sure that the product is excellent. Yeah, so thank you so much again for inviting me.
Yeah, cool. And thank you for joining us. The live Quack and Code is happening every other week. So don't hesitate to join the LinkedIn page, follow, or the YouTube channel. We are streaming from both LinkedIn and YouTube all the time. And you can follow up with the events on the events page, motherduck.com/events, if you want to don't miss other Quack and Code event or other in person or online events. And have a great end of the week.